everyone, and welcome to our first part of Unit 9. We're going to go ahead and talk about polygons and putting polygons on the coordinate plane today. You should have reviewed parallel and perpendicular lines from Monday or Tuesday's lesson. You should have watched the video and refreshed yourself about their slopes and the relationships that they have on the coordinate plane. You're going to want to probably have graph paper out for this lesson, and don't forget you can always pause and stop the video in order to take notes as you go. You will have a couple of examples within your notes today, and then you will have your homework, which is attached in this video and also in the blank document that represents these notes that is posted on Teams and on Portal. So let's go ahead and get started. If you will, take a few minutes, go ahead and pause the video, and think about how to answer the following question. So go ahead and pause. If you were to go forward in proving the following statements true by showing your work, we're going to need to refer to the slopes of these lines. So number 1 says that line 1 is parallel to line 3. Well, if we need to prove that lines are parallel, remember our first go-to is to prove that the slopes are equal. So we're going to go ahead and see if that is the case. If the slopes are equal, that means that we can find 2 points on the line. So let's go ahead on line 1. Here's a nice easy point on line 1, and here's another nice easy point on line 1. Our slope is our rise over run, so I could rise 2 over 1. Unfortunately, Ms. Rodak's dotted line drawing has gone away, or my skills have not been very good with this stylus that I have to use. So you're going to have to deal with solid lines. I know some of you will be devastated. Then if we look at line 3, we can also find 2 nice points. Here's one, and here's one. If we do our rise over run here, it is the same as 2 over 1. So we would say that line 1 is parallel to line 3. They both have a slope of up 2 and over 1, or that gives us a positive slope of 2 over 1. Similarly, we can go ahead and check our work for statement 2. It says that line 2 is perpendicular to line 4. Well, remember, for perpendicular, we need to show that slopes are opposite reciprocals. We're going to go opposite recip. That's how we're going to abbreviate that. So let's find 2 nice points. Here's a nice point. Let's start with line 2. Here's a nice point on line 2, and here's another nice point. Our slope this time is up 1 and then over 2. If we go down here to line 4, here's a nice point, here's a nice point. Our slope this time is up 2 and over 1. Or, if you don't like that, you can go ahead and think about the slope being rise over run from the same 2 points down to over 1. So, this time, since we're going down, I'm going to call this a -2 and a +1. So if we look at our slopes here for line 2, our slope is up 1 over 2. So our slope is 1/2. For line 4, our slope is down 2 over 1, which gives us a -2 over 1. And in fact, 1 over 2 and a -2 over 1, those are opposite reciprocals. So we would say that those lines are perpendicular. So we could say that line 2 is perpendicular to line 4. We can go ahead and say that that is true. So as we move forward today, let's go ahead and think. Explain how you could justify the figure as a square. Pause your video and think for a quick second. After you've thought, hopefully you've come up with a couple of different ways that you could prove this thing is a square. Perhaps one method would be to show that all sides are congruent. And how could we do that? Well, we could use the Pythagorean theorem. Another method would be to show opposite sides are parallel. And we just reviewed how to show parallel sides by using their slopes. And we could even go farther, and we could show that adjacent sides are perpendicular to each other by showing that they have opposite reciprocal slopes. So don't forget, we can always draw a triangle on our graph, and if we can count the distance here from, let's say, 3 to 8, that would be a total distance of 5, or we could count our spaces. And the distance from -4 to 1, that would be a total of 5. So this value would be the C value of this right triangle. So we could simply do 5 squared plus 5 squared equals C squared, and then C would equal the square root of 25 plus 25, or the square root of 50, which we could leave as a radical for right now. But if we can then show that all of these other triangles made around our shape are also 5 by 5 triangles, which in fact they are, we can say that all of the sides of the triangle, or all of the sides of the square, have to be congruent, because we would end up doing the same Pythagorean theorem 4 times. So that would be one way we could show the idea for number 1. But as we keep moving, let's go ahead and review the properties that we have for our shapes, because we're going to have to put these shapes onto the coordinate plane. Once we put these shapes on the coordinate plane, we're then going to have to be able to classify them by their properties. So let's just do a quick review. Go ahead and make a chart on your paper. Let's just do a quick review of the properties that we would need to show and how we could actually show them. So for a right triangle, we would need to show that 2 of the sides of the triangle are perpendicular to each other. And we show that by opposite reciprocal slopes. This would justify the right angle and therefore the right triangle. An equilateral triangle, we'd have to show 3 congruent sides. And to show congruent sides on a coordinate plane, we would use the Pythagorean theorem, which you guys should know by now is a squared plus b squared equals c squared. Okay, isosceles triangle, we would show 2 congruent sides, and then we would simply go ahead and use Pythagorean theorem there. We're resorting to the Pythagorean theorem instead of the distance formula just for the sake of efficiency. It's a lot easier to go ahead and draw triangles on your graph than it is to use your distance formula 3 different times. And last but not least, for a scalene triangle, we would have to show 3 non-congruent sides. And with that, we would still use the Pythagorean theorem. As we go on to as we go forward to different shapes that we could also put on the coordinate plane, let's talk about the properties of quadrilaterals or 4-sided figures. So for a square, your square is like the most loaded shape that you're going to have on the coordinate plane. You would have to show 4 congruent sides using Pythagorean theorem. You'd have to show that opposite sides are parallel, showing same slopes. And you'd have to show that adjacent sides are perpendicular, showing opposite reciprocal slopes. As we move forward for a rectangle, instead of all 4 sides being congruent, we would just have to show opposite sides congruent. And we would still use, we're going to resort to P theorem on this one. And then we'd still have to show opposite sides parallel, and we'd have to show opposite sides, or I'm sorry, adjacent sides are perpendicular. And we would go ahead and use the same criteria here with our slopes. For a rhombus, we get even less specific. All we'd have to show here is 4 congruent sides using Pythagorean theorem. And this time, there's no specific relationship with the angles, so as long as we can show 4 congruent sides, then we don't have to prove right angles or anything there. We would just have to show that it's also a parallelogram and show that opposite sides are parallel using same slope. And finally, even less specific, for a parallelogram, it does not require that all sides are congruent. It just requires that opposite sides are congruent, and we'd use the Pythagorean theorem again. And this one would show that opposite sides are parallel, and we'd have to show same slopes. So take a minute and just kind of digest. Our square is the most specific. We'd have to show the most content. Rectangle, a little less specific. It still has 4 90-degree angles, so we still have to show the perpendicular sides and the opposite reciprocal slopes, but the sides this time don't have to all be congruent. Rhombus, even less specific, 4 congruent sides, and then a parallelogram, even less specific, with just opposite sides parallel and opposite sides congruent. Last set of 4-sided shapes would be a trapezoid. So for a trapezoid, all we need to show are the bases are congruent, or one pair of parallel sides. That's all we need to show there, and we would just use same slope for that. Now for an isosceles, we're going to have to show one pair of parallel sides and the same slope, and we'll have to show that the legs are congruent, and we would go ahead and use Pythagorean theorem for that. For a quadrilateral, all you got to show is that you have a 4-sided closed figure. Just graphing involved on that one. If there's no specifics with the side lengths or with the angle measures, then you just show that 4 sides make a closed figure. For a kite, we would need 2 pairs of adjacent congruent sides. And we would go ahead and show that using Pythagorean theorem. All right, so let's go ahead and show you on a graph what I actually mean by classification of sides and what all these properties actually have to do with this topic. So if we look here, triangle XYZ has coordinates 1, 2 for X, Y is at 5, 8, and Z is at 8, 6. Go ahead and graph this on your paper, and I'll show you what I mean by the classification. So if we're going to classify our triangle, equilateral, isosceles, or scalene, we simply need to show the properties of the sides. So we're going to go ahead and test the sides. And when we test the sides, we use Pythagorean theorem. So I'm going to go ahead and just kind of draw myself, oh, there was the beginning of a nice dotted line, some right triangles that go from point to point. If I'm traveling here, if I'm moving along this x-axis, I'm going to travel from an x-coordinate of 1 to an x-coordinate of 8 to give me a total distance of 7. Or I could simply count my boxes, 1, 2, 3, 4, 5, 6, 7. Moving up, I look along my y-axis. I'm going from a coordinate of 2 to a coordinate of 6, which would be 4 units, or I could simply count. And then you can keep going all the way around your shape. This would be a 2 by 3 right triangle. Notice these are 90-degree angles here. And then this last guy, this guy would be moving up and down. This would be a 1, 2, 3, 4 by 6 right triangle. Now, if you are well versed in your Pythagorean theorem, you could probably already go ahead and jump to the conclusion of what kind of triangle this is actually going to be. If we look here, each of these values, so this would be a C value for a right triangle, this would be a C value for a right triangle, and so would this. So these are all going to be C values. So we could literally set up 3 different Pythagorean theorem equations. Okay, so for side YZ, I'm going to say that if I use my Pythagorean theorem, 2 squared plus 3 squared equals C squared. Square both of those, 2 squared is 4, 3 squared is 9, add them up, C is going to be equal to the square root of 13. So that would be the value for YZ. Now if we keep looking, let's say we went over here to XZ. We would use the Pythagorean theorem now with 7 squared and 4 squared. But this time, 49 plus our 16, we already know that the 49 and the 16 are different from the 4 and the 9 that we got from the previous side. So even if we did our Pythagorean theorem here, we're going to get C is the square root of 65, and that is still different than our previous side YZ. So we could keep going even further if you're still not satisfied or convinced yet, but XY would be the square root of 6 squared plus 4 squared. Well, 6 squared gives you 36, and then 4 squared gives you 16. So if you did the square root of the sum of those, you would get the square root of 52. So, because all of these are different, we would go ahead and classify this shape as a scalene triangle. As far as work would go, this would be acceptable here. All right, so we'd have 3 non-congruent sides. This would be acceptable for you to show on a piece of paper or a problem to get full credit. So let's go ahead. You guys go ahead and try one. Pause your video, go ahead and graph your image or your triangle on your coordinate plane and see if you can classify it as equilateral, isosceles, or scalene based off of the sides. Check your answer here. You should have gotten an isosceles triangle for your answer by showing that 2 of the sides were congruent. Next, let's move on to 4-sided figures. So now we're going to classify this shape. We have quadrilateral STUR, and it has coordinates STU and R already graphed on this coordinate plane. If we look here, this shape is obviously not a square, obviously not a rectangle because we don't have perpendicular sides. But we could go ahead and still justify that. So our leading options now are probably going to be parallelogram or rhombus. We could probably go ahead and roll out rhombus also because we can clearly see the sides are not congruent. But it's all about showing me what you know. So you need to still be able to justify your work. So we're still going to go ahead and we're going to test the sides. So when we test our sides, let's go ahead. We can draw our triangles. I'm going to go ahead and start with opposite sides since I thought this thing was a parallelogram. And these are both 1/3 triangles. So I know that SR must equal TU simply because they would both equal the square root of, if I did 1 squared plus 3 squared equals C squared, I know C is going to equal the square root of 3 squared is 9 plus 1 or the square root of 10. So I can go ahead and mark those congruent. And I know that SR is going to be congruent to TU. If I checked another pair of sides, so if I make this triangle, I'm going to have a 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6 sided triangle. That's a 6 up there. If I do my right triangle from these 2 points, from R to U, I have, oh looky there, a 4 by 6 triangle also. So again, I'm going to go ahead and say that ST must be equal to RU. And if I was to show my work here, which is what is needed, 4 squared plus 6 squared equals C squared. So you guys should be comfortable by now. If you do 6 squared, you get 36. And then you do 4 squared, you get 16. This would be the square root of 52. So now I've just shown that I have opposite sides congruent. Notice, not all 4 sides congruent, but I've shown that opposite sides are congruent. So I've shown that property. That's actually a property of all of those shapes up there, rhombus, square, rectangle, or parallelogram. So I next need to move to testing my slopes. So if I test my slopes here, this is the beauty of doing the Pythagorean theorem the way we did it, because we basically have our slopes already on our graph. If we're looking, we need to know that opposite sides have the same slopes. So let's check the slopes for, let's say, side SR. For side SR, my slope goes down 3, and my slope goes up 3 and over 1. So my slope is going up 3 and then over 1 to give me a positive slope of 3 over 1, or 3. The side I need it to be equal to is side UT, or side TU, as we previously referenced. So if I look here, I'm going up and over, or I can go ahead and already use my 3 and my 1 that I already drew on my figure, or on my graph. So this would be positive 3 and then over 1 to give me a positive 3 over 1. So because these are equal, we can say these sides are parallel. And I can go ahead and mark that on my diagram. I'm going to extend down here just a quick second, but we're now going to test our other sides. So let's go ahead and test side ST. My slope for ST, remember it's rise over run, so my slope was going to be a rise or a rise of 4, or simply we're going to be going down 4, and then we're running 6. So our slope here is negative 4 over 6. And if you are comfortable with simplification, obviously you can simplify or leave it, but negative 4 over 6, the common factor is 2, so this would be a negative 2/3. We need this side to have the same slope as side RU. So let's go ahead and check it out. RU has a slope of down 4 over 6, so down 4 over 6 is the same as negative 4 over 6, which is the same as this guy. So these sides are parallel. So my final classification, I now can look at these two slopes here. If I look at my slopes of my adjacent sides, so let's say side TU is adjacent to side RU. We know that 3 over 1 and negative 4 over 6 are not opposite reciprocals. So we can go ahead and rule out the fact that our sides are not perpendicular. So our classification here would simply be a parallelogram. We have opposite sides congruent, and then opposite sides parallel. Go ahead and try one. Graph this on your paper, and go ahead and start testing your sides and testing your slopes and see if you can classify this shape. Check your work by reviewing here. This quadrilateral would in fact be a rectangle. Please be sure that you showed that the opposite sides were congruent. You showed that opposite sides had the same slope, which makes them parallel. And you showed that adjacent sides have slopes that are opposite reciprocals, which then prove that all of your sides are meeting at 90-degree angles. So because all of the sides are opposite and congruent, opposite and parallel, and then adjacent sides are perpendicular, you would have a rectangle. Moving forward, last one. So this would be another type of quadrilateral where we're now classifying as kite, trapezoid, or isosceles trapezoid. Remember, for a kite, we need two pairs of adjacent congruent sides. We can clearly see that this is not a kite because we know that CD is not congruent to AD. We can see that that's not congruent to BA, and we can also see that CB is the longest. So we can go ahead and rule out kite. But our trapezoid, so trapezoid we need to show at least one pair of parallel sides, and then for the isosceles trapezoid we need to check for the congruency of the legs. So let's go ahead, let's check for parallel sides. So let's go ahead and test our slopes. Our slopes that we have, that would be parallel, or our slopes that would show us parallel sides would be the slope for side BC and the slope for side AD. So let's go ahead from B to C. Our rise would be up 3, and then our run, so if we're going up 3 and then we're running 1, 2, 3, 4, 5, 6, we're showing that we have, for side BC, a slope of up 3 and over 6, so this gives us a positive 1/2. For side AD, we could go ahead and show our rise over run of up 1 over 2. So our slope here, up 1 and then over 2, gives us a positive 1/2. So we can go ahead and say these sides are in fact parallel to each other. So we've got the trapezoid and isosceles trapezoid property laid out. Last thing is we need to test the side lengths. So if we're going to test the sides, or specifically our legs, we need to see if CD is congruent to AB. So let's go ahead, let's draw our triangles here. So this would be a 1/4 triangle, and this would be a 2/3 triangle. Well, we know that 1 squared plus 4 squared does not equal 2 squared plus 3 squared, which would be the process of using our Pythagorean theorem. Or in fact, CD would equal the square root of 4 squared plus 1 squared, which would be the square root of 17. And then BA would be equal to the square root of 2 squared plus 3 squared, or 4 plus 9, which is the square root of 13. They are not congruent. So it is not an isosceles trapezoid, and you would simply pick trapezoid. This would be acceptable work. Make sure you would be able to show this using your slopes, using Pythagorean theorem. Go ahead and try this last example on your own. Pause the video. And go ahead and check your work. So with this one, you need to check your side lengths. This one, obviously, a trapezoid was out. There's no parallel sides on there. No sense in testing the slope. You just need to show that you have 2 congruent sides, and you also have another pair of 2 congruent sides. This is your homework. This homework is actually due for you on Friday. So anytime by the end of the day on Friday, you need to have this completed. The first task is to go ahead and log on to Mathia, which is the platform that we've been using through Clever. You need to complete the first unit only, and it's only 2 workspaces. It's in Module 3. Module 3 should be unlocked for you. Make sure you complete that. Once you get to the second unit involving proofs, you're done. You don't need to go any further. And then number 2 for your homework, on your own piece of graph paper, go ahead and graph plot these shapes and use the notes that we just took here and the procedures that we just went over to classify these shapes. Classify them into their most specific name. So if it's a quadrilateral, test all the sides, test all the slopes to see if it's most specific, and use those use the list of properties that we went over. All right, thank you for listening and have a good productive day.